This is the third video in the series, and we're going to assume some knowledge of naming. Now, we're going to look at how to name, in IUPAC nomenclature, alkanes that have functional groups. Functional groups are groups that are attached to the alkane which will be reactive and determine the kinds of reactions the alkane will undergo. So, this alkane has halogen substituents, chlorine and bromine. That makes it an alkyl halide. Again, we number to find the longest parent chain, and if there are two parent hydrocarbons with the same length, we're going to use the parent that yields the greatest number of substituents. So 7's the biggest one we can get, and this one yields the greatest number of substituents, so we'll use it. Now, if we number from this direction, we have substituents coming off at carbon 2, 5, and 6. But if we number this way, we have substituents coming off at 2, 3, and 6. 2, 3, and 6 is lower than 2, 5, and 6, so this is the way we will number. Now, we've got bromo for the prefix for bromine, and chloro for the prefix for chlorine. We see here that we have two bromines coming off at 6. Bromine comes before chlorine, comes before ethyl, the names of our substituents in the alphabet. So we will label this molecule 6,6-dibromo, 2-chloro, 3-ethyl heptane, because it has 7 carbons. Let's look at a couple of ethers. Ethers happen when one of the carbons in the carbon chain is replaced by oxygen. Ethers can be symmetrical or asymmetrical. For ethers, we're going to talk about the common name of the ether as well as the IUPAC name. So the common name of the ether are the substituent groups listed alphabetically, considering each as a substituent, followed by the word ether. So on this side we have methylbutyl, and on the other side we have a methyl, so this would be methyl 1-methylbutyl ether. This symmetrical ether would just be dipropyl ether in common name. For IUPAC, we take the longest carbon chain and we call that the parent, and then we label the substituent by replacing the YL normally found with oxy. That makes the asymmetrical ether 1-methoxy 1-methylbutane. That makes the symmetrical ether, with propanes on either side, propoxy propane.